Yes, I think we'll have a lot to talk about, Connor. Looking forward to it. Welcome, everyone. Exciting to see people trickling into the room. Just giving it maybe 1 minute more to allow more people to come in. And while we're waiting, if you feel comfortable to share where you're dialing in from, your also maybe area of expertise, that helps the speaker to identify the audience and be kind of cater the presentation a bit to the audience geography and needs. And also, while the presentation is happening, if you do have some questions, please do feel free to use the Q&A. Oh my goodness, do we already have a question before we get started? No, somebody who's just putting their hello in the Q&A. Okay. Thank you for that, though. Michelle from Italy. All right. I think in the interest of time, we'll get started now. So welcome, everyone. I am Valerie de Liedekerke from the AIR Center. That stands for Atlantic International Research Center. And I am also the coordinator of the Blue Mission Atlantic and Arctic Coordination and Support Action Hub under the mission notion, Restore Our Ocean and Waters by 2030. So today we're going to be covering the topic of the digital twin. So I'm just going to introduce a little bit what the digital twin of the ocean is. And then also I will introduce our speaker and then hand over to our speaker to present. And then afterwards we will have a Q&A. So a digital twin of the ocean is a virtual representation of global marine and coastal environments, providing access to real-time and historical data from sensors and satellites. By integrating advanced technologies like numerical modeling, AI, machine learning, and high-performance computing, digital twins are able to generate the information needed to design the most effective and sustainable ways of protecting marine and coastal habitats, supporting a more sustainable blue economy, and mitigating and adapting to climate change. The European Digital Twin of the Ocean, launched by the European Commission on February 22, aims to make ocean information accessible to policymakers, researchers, businesses, and citizens. The project, funded by the EU, involves the development of interactive tools and a digital ecosystem through the EDITO R&D projects, with the goal of achieving an operational digital twin by 2024. EDITO Infra is a joint EMODnet and Copernicus Marine Service project to publish their respective data products on a common data lake that will provide fast, robust, and scalable data access and computing. So our speaker today will showcase the successful centralization of EMODnet and demonstrate how to find the download and download the data products of EMODnet. So I wanted to introduce Dr. Conor Delaney. He is the technical coordinator at the Secretariat of the European Marine Observation and Data Network, which is EMODnet. a marine data sharing service of the European Commission Directorate General of Maritime Affairs and Fisheries. Conor has over 20 years of experience working across the disciplines of information communication technologies, environmental science, and big data, participating in research projects and delivering information technology solutions in both the public and private sectors. A strong advocate of open data, Conor has worked as an environmental data scientist for Amazon on their public data program, which involved collaborating with NOAA on ways to improve access to big data. Conor has a PhD in atmospheric physics and an MSc in environmental science. He has extensive knowledge of marine, atmospheric, and Earth observation data. Over to you, Conor. Thank you.
Thank you. Wow, that sounds great. Thanks very much for that. Can you hear me okay? Yeah, okay,
Yes,
I'll just
fine.
share my screen now. Are you seeing the presentation?
Yes, perfect.
Okay, thank you very much for that, and thank you for that nice introduction. As you know, Conor Delaney, and I'm going to go slowly through my set of slides, being aware that sometimes I can, as an Irish person, I can end up speaking very quickly, and I want to keep things quite slow. And I'm not going to get too technical, but I want to give you enough information that when this presentation is finished, you can understand the status of the European Digital Twin of the Ocean Infrastructure and EMODnet, and something of Copernicus Marine, and that you have an understanding of the direction of marine data sharing is going. So on my first slide here, I just wanted to mention acronyms and get them out of the way. So an SDI, Spatial Data Infrastructure, is a data infrastructure for implementing a framework of geographic data. Software client is used to display such data, like a web map service. Catalog service is used for discovering geospatial data, and then a spatial data service is used for serving that spatial data to the catalog and to the software client. So why do I mention this? Well, since 2007, and since the INSPIRE directive, member states have to have infrastructures for spatial data information in Europe. And a lot of what we do in EMODnet is based on the outcomes of the INSPIRE directive. For example, we use a lot of open geospatial consortium web standards, which are widely used to meet the needs of the INSPIRE directive. We use web feature services for downloading data. If you think of a point on a map and downloading the data associated with a point. Web mapping services for visual making and visualization of a map. And the catalog service for the web for creating catalogs. And the other point I wanted to raise here, or I think I want to remind you of here, is that in 2019, the Open Data Directive for Europe was refreshed, and all member states have signed up to it, and they have all, it's very much, I had a quick look at the latest review of the reporting on it, and they are very much embracing the terms of the Open Data Directive. So I just want to mention these now. I won't go, I have one more slide on acronyms way later in the presentation, but just in case some of the things I say are confusing. And of course, feel free to ask questions at the end. So EMODnet. We're a trusted in situ marine data service, open and free to all. So what does that mean in reality? Well, what you have in Europe are the member states who are loosely federated or loosely gathered together, and the European Commission, which is like our civil service. So if I'm from, for example, I'm from Ireland, and my country takes surveys of the ocean floor, and we publish them for the ocean floor, we're only obliged, we don't do it for our own territories. So something like EMODnet takes data products from member states and other sources and combines them to create European scale data products, like a European scale bathymetry product or a European scale biodiversity product. So we have 7 thematic domains. We have biology. You can see them here in the diagram, from the seabed up to the top of the water column, and they cover a number of different subject matter areas, from human activities to physics, for example. So they're quite diverse. They're quite different communities. So it's a big challenge. So we have quite a big network who work on bringing together these data sets and creating standardized and harmonized data products, which, because they're funded by the European Commission, are open data. So they come with a Creative Commons by 4.0 open data license, so that you are free to use and download them and use them as you see fit. So some of the key products here are, just to give you an overview, and there's a little QR code at the top would lead to our product catalog portfolio. There's bathymetry, the physics, the chemistry, which looks also at marine litter, biology, which has also a global reach because it's tied in with the global biodiversity network, the geology, the seabed habitats, and the human activities. And in the human activities picture there, you're seeing ship traffic data, but they do lots of other things. So we also work together. We use within our organization, we use each other's products. So for the EUC map, which is a model of the seabed habitats for Europe, they take in data from physics and from bathymetry and from biology and use these together to create the European scale predictive habitat map. And we have a nice little animation to show that. So we are actually using our own products, which means we have our own, we trust our own work, in a way of putting that. So just to refresh, how does all this work, or what are the drivers behind this? So as I said earlier on, the Inspire Directive is one of the things that we rely on in terms of getting access to geospatial data. We follow the FAIR principles, but most importantly, we follow the open data principles. I don't know if you know what FAIR, which is findable, accessible, interoperable, and reusable data, doesn't necessarily mean that data is open. So our preferences start with open data and then work up from there. We have aggregated, harmonized, multi-parameter data sets, which I think that's quite clear to you. Searchable metadata, integrated data products like the maps, and then the data services for visualizing and querying the data sets. So we're also, and this is very important, we are a long-term service. We are part of DG Mare. We are hosted on European Commission domain. So we're not like a Horizon project, which generates a portal and then disappears when the funding's gone. We're here for the long term. So you can always rely on us to be around. But what I wanted to illustrate here in this pictures, this is an old diagram of EMODnet. And if you see on the top right-hand corner there in the infographic, the thematic groups or thematic lots broken into their areas, bathymetry, biology, etc. And this is how EMODnet used to be presented to the user. Now we go to the next slide, you'll see here that each EMODnet thematic group had its own separate web portal, its own separate map viewer, its own separate data catalog, and its own separate URL. So you had to go to each of these different portals if you wanted to build a portfolio of data products that you wanted to work on, which was not very helpful because each of them had separate protocols for downloading data. Some of them you had to log in. They had different types of map viewers. The map viewers worked differently. The formats were different across the portals. So this was not ideal. And the Commission was not happy with this either. They wanted users to have a consistent experience when accessing EMODnet products, because the products are very valuable. I mean, there's no one else producing European scale products. So from January 2023, we switched over to one map viewer, one website. We're only now on, so if you search for EMODnet, you just get the one at the posted at DG Mare. All the portals were switched off. One catalog, and we brought in a new technology from our colleagues in NOAA in the United States to help us manage large, big data, gridded data sets. So all those map viewers are gone. You now have one consistent entry point into the EMODnet catalog. And I'll talk about this for a while and explain a bit more. But as you can see in the map viewer there's the catalog on the left, and that represents all the different thematics. So the core products from those thematics are in that catalog. We also had to harmonize all the information on each of the portals into consistent presentation because we were being hosted onto the European Commission. That means in terms of how things look, in terms of fonts and colors, and also the amount of menus you can have, because the Commission is very strict on how information is presented on European Commission websites. And this worked out great for us because it allowed us to greatly consolidate information across the thematic blocks, and each of the subject matter areas has a page on the new website where you can go in and find the reports, the technical reports, descriptions of metadata, the descriptions of how the products are made. They're all there, and it's all searchable. So here's our glamorous infographic from last year, where we launched in January the new EMODnet with the one map viewer, the one catalog, uniting all the different portals. And we're now at the moment coming to the end of the centralization phase, because we are also integrating the data ingestion portal, so that you will be able to come to the EMODnet website and submit data to the EMODnet network through the data ingestion system that will be on the web page at DG Mari. Now, in case you're wondering here, this all is relevant to EDITO, so I will come back to this later. So just have to trust me in this for the moment. So I will go quickly over the some of the features of the map viewer, because it ties into what we're trying to do. So if you could use the map viewer, first I want to make sure that you understand it's not a geographical information system. There is no data processing here, and we're not promoting or publishing data products that are used that are policy related, i.e. we're not making decisions or doing insights on policy matters. It's up to people who use our products to do that. On the left-hand side in our map viewer, all the tools are to do with finding our catalog products, finding in our catalog the products, presenting them on screen, querying them, or changing the way they're presented, because you can change the projection. And on the right-hand side, it's tools on how you can zoom in and print off what you see on the screen, etc. All these are there to help you better interact with our data products, and then find out what you need to find the bits you need to use. And once again, here we have this is a nice example. This is the human activities ship routing data product. So this is a good example of what EMODnet is about. As some of you are aware, ships carry a thing called an AIS transponder for safety reasons, and that signals every few minutes where the ship is at sea, and all boats over a certain size have to carry this. The data is actually collected by some data aggregators, and can be quite, and is very expensive. I was going to say it can be quite expensive, but it is very expensive. So if you're a researcher or an individual, it's usually out of reach for you. But what we do in EMODnet, our colleagues purchase this data set and create this data product. And the data product is, because it's funded by the Commission, is free for you to download and use. So this is an example of our community approach with the data products. We're trying to build things so the whole community can use them. So I'll go back to the map viewer here on the right-hand side, just to give you some of the features. What I've done here is I've opened up the bathymetry digital terrain model. So this is the depth from lowest astronomical tide of all around Europe. And also I've opened up in the background there, I think I can't really see the screen, but I think it's wind farms. And we built in tools that allow you to just draw a box around the area of interest and download the data in the format you want. Now, for this, this didn't exist before. We didn't have this in the old version of EMODnet. We didn't even have a unified digital terrain model for Europe. The digital terrain model for Europe existed in 64 separate tiles. And one of the things we did as part of the whole centralization was consolidate all that into one big file. It's those of you who know would be a NetCDF file, which is a gridded file format used in oceanography. And this is a big data set tile, so about 136 gigabytes. But you can zoom in and draw a box and download the area of interest. And it's revolutionized the way people are using our bathymetry product. And the amount of downloads we have for bathymetry products has grown tremendously since we centralized. And just while I'm here, I just want to talk a bit more as an aside about the bathymetry DTM so that you get an understanding once again of how we do things. So the bathymetry thematic group, they produce a new DTM every 2 years. And what they do when they're starting to prepare a new DTM is they harvest data from a system that keeps an eye on what member states are doing in terms of doing surveys at sea. I can see that here in the left-hand side. This is a map that's on the portal, on the map viewer, that shows all the different patches in the sea that have been surveyed or are surveyed on a regular basis by member states and sometimes some private companies. And this is indexed and cataloged. And on the right-hand side there, I've clicked on a patch off in between UK and France there, and you can see on the right-hand side details about that survey. And some of these surveys are not open. The data is not open. Some of them is restricted, but they're open to us in EMODnet to allow us to build the digital terrain model. The reason why some member states restrict the data is for security reasons. Other member states like Ireland, it doesn't restrict its seabed surveys, but especially with the activities of the Russians that happened around in the Baltic Sea, there was some other member states shut down the access to these surveys. But anyway, that gives you an idea. It's how the bathymetry DTM do it. The biology does something similar, and but not all thematics do exactly the same thing. But it's in general principle how things are done. So here we go with biodiversity. This is biology. Very, very, very different type of data, but we've implemented the same workflow for downloading the data product. You can go in, zoom in, choose a species. In this case, it's orca whales. Choose an area, it's coast of Norway, and then draw a box, and then you will get the occurrence data for orca whales in that region. And if you click on a dot, you can get the actual record for that dot. But even though the data is very different to what you see for bathymetry, the approach to subsetting and downloading data is the same. And also include here something on marine spatial planning. So I know Valerie would be interested in this. We have a human activities team are integrating links in the data sets to the marine spatial plans that member states are making available. And if you click on the polygons in question, you'll get more details on that. Also, for example, off the coast in the English Channel, North Sea, for the aggregate and extraction areas, you'll be able to click on those areas and get to see the license information on who's doing the gravel extraction or sand extraction. So I illustrate this here because the interaction with the data is the same as to have the interaction with the other data products, but once again, it's a very different data product from the DTM or the biology. And here I show you the European Sea Map. This is one of our the seabed habitats product. It's one of our premier products, our showcase products. You saw how it was built earlier on, but if we weren't doing it, I don't think anybody else would be doing it. So it's important to understand that there are gaps in what we do in Europe caused by how we're structured. So in this case, it's the Commission that stepped in, particularly DG Murray, to fill that gap so that these things get built. So that's what you're looking at there was the map viewer, but the map viewer it gets all its information from our catalog. So we have one central catalog, which has over 2,000 data products in it. All of them have extensive metadata. All of them, most of them anyway, have links to how you can download the data itself. And there is nothing in the map viewer that isn't available in the catalog. So we're very transparent as to what we do with or what we make display on the EMODnet portal. So we believe that if you can see it in the catalog, you can actually, if you see it in the map viewer, you should be able to get in the catalog. If you can see it in the catalog, you can actually import it into the map viewer too, if you want to. And then also I wanted to bring up this, that we also have this thing called an ERDAP server, which is another new thing for us. And this is how we present gridded data sets, say for the bathymetry TM or for modeled eutrophication. And allows us to subset the data sets and present them in a number of different formats to the user. So you can access, when you do the subsetting on the map viewer, it's creating API calls to this, but you can also access this directly and use it yourself. We are also working very closely with our colleagues in other services like Copernicus Marine and say who also have ERDAP servers, so that these are all interoperable. And as a result of our activities with ERDAP, we are also on the member of the advisory board of NOAA's ERDAP development team, which is the first for NOAA. For NOAA had never asked anybody externally to be on one of our advisory teams, which is great for us because this technology has been used all over the world now. Now, going back to what I said earlier on about, we're very keen that people realize that what you see in the map viewer is available in the catalog. It's the same goes for the web services. Now, the web services, remember, those are the OGC web services, which are used to make our system Inspire compatible. And we also rely on Inspire standards. All the web services that we use are published on GitHub. They're also available on a forum page on our website. So you could technically come along and build your own map viewer and never actually talk to us, or you just use the web services because there's no logins. They're open web services, so you're free to go and interact with our data products and build your own map viewer if you wish to. So as I said earlier on, I really want to assure you this is all relevant to the digital twin. So we'll move on now towards the world of digital twins. And the first question that everybody says, what is a digital twin? Well, for me, we all have different takes on this, and I come from a time where decision support systems were were the thing, and I see digital twins as a very sophisticated and better type of decision support system tool. And indeed, this is what the Commission wants people to achieve with digital twins. They want the data to be available rapidly and at scale and at high enough resolution so that people can use them to do decision support as a result of what demands are put on them because of European legislation. And that's my take on it. Other people will give you a different take on it, but I think from the point of view this exercise, it's a good way to go. So we are building what's called the European Digital Twin of the Ocean infrastructure. And this was the upshot of a meeting that we had at the Digital Ocean Forum in Paris 2 years ago or 3 years ago between Copernicus Marine and ourselves, where we realized that with the growing demands of machine learning, that our infrastructures are not ideally suited to serving those needs. So what I mean by that, and I'll explain more in a moment, machine learning algorithms are constantly looking for data, rerunning the models when data gets updated. And that's not the workflow that we developed in EMODnet. It's more to do with spatial data, downloading the data products, and working on them separately. So I have a slide here to explain this. Sorry, it's a bit technical, so we'll spend a moment or two going over it. So imagine you're on the far left-hand side. You've got a browser, or you've got a GIS system, or you're working Python or and you want to work with EMODnet data. So what you do is you navigate across the internet to our map viewer. And through our map viewer, you find out that there are some products in our catalog. And from the catalog, you then send out a request to get the data you want from one of the 7 separate servers located all around Europe. So you've gone across the internet into our system, which is hosted in Flanders Marine Institute, out of there again onto the internet to the data server, and then that sends the data all the way back to you in your home, wherever that is. And then you have to do that for each of the products that you want to work on. So your first task you have is the time it takes to download the data, which is dependent on your network speed. And then there's the time it takes for the services to give you the data, which is dependent on the complexity of the data and the demand for the data. And of course, the time taken to navigate across the internet to where those data products are. This is grand if you are working in that type of workflow, and this workflow is not going to change. EMODnet is always going to have this workflow aimed at people working on geospatial analysis. But for machine learning routines, or AI routines, if you want to call them, it's not ideal. So what we realized when working with Copernicus Marine, that we need to adopt a new approach, especially if we wanted to make sure that our products were serving the needs of people building digital twins. So I have a diagram here to try and illustrate that. So you are still on the left-hand side, but this time you log into a domain within the internet. You've logged into, it's actually a data farm or a data site server in Poland, in this case. And in there we have a data lake containing the EMODnet products and the Copernicus Marine products. And you then run your Jupyter Notebook or your QGIS or your Studio or any other languages they're using from a virtual machine located in the same place. So the data is no longer flowing across the internet to your home. You're working on it right beside where it's located in the data center. In this case, as I mentioned, in Poland. So the performance characteristics have dramatically improved. You also reassure that you're working with the latest data products as they're available. And it's scalable so that you can, if you build an application, you can launch it and send it out to the internet, and other people can use it. I'll give you an illustration of that in a moment. But just this is my second acronym slide coming up now. What is a data lake? A data lake is a collection of semi-structured and structured data products or data sets on a very fast storage mechanism. So what we're using is a simple object storage, which is a technology that Amazon use, but it's also an open source technology that allows, like if you put pictures in a Dropbox, or you put your documents in Google Drive, it's very fast to access this. You don't work on the data there. You subset it, you download it to work on it, or you use other technologies to subset the data, which I'll come to in a moment. And then we make the data products available through a spatial temporal asset catalog, which is a very simple catalog that just allows you to find the products you're interested in and download the data product directly. So that's my last acronym slide. And I just go over now to the EDITO, Digital Twin in the Ocean. It exists now. We launched this in beta form. So in last week or 2 weeks ago, so it's in beta testing mode. That will be expanded in September, but you can go to this site dive.edito.eu and you can explore what we have there and see what people are doing, but you won't be able to log in unless you're part of the beta testing program. And the beta testing program at the moment is quite restricted because we want to just make sure everything's working fine. But if you're on there, you will see things like the Copernicus data products on EDITO. So this is a stack catalog listing the data products which have been stored in the data lake on EDITO. And some of those are in what's called cloud optimized formats. So what happens in a cloud optimized format? You take a very big data set like EMODnet bathymetry, which is a 136 gigabyte netcdf file, and you explode it into smaller pieces, which you store across the data lake. So then when somebody comes looking for subsetting it, they have very fast access to a subset of that data. And then they only need to work on the bits of data that they want to work on at any particular time. The data itself is also available in the full format if you want it. But the other way of presenting the data is much more in tune with building machine learning models. The EMODnet products are up there too. All the EMODnet products that are in the map viewer are also up on the data lake. The other 2000, I think, that are on the catalog are not there yet. But we're focusing on getting the ones on the map viewer up. And some of them are being converted into cloud optimized formats too. And a simple stack catalog, as you see on the screen here, is a very simple text file that exists in the data lake bucket where your data has been stored, and then it's rendered into a web page that gives you basic parameters that allows you to work, find out what you're looking for. Here we have some more of the EMODnet ones. So the type of catalog we have on the map viewer on the EMODnet website is much more sophisticated, but this does the job for working in the EDITO. And then, of course, there's services that are available. There's a dashboard that allows you to set up Jupyter notebooks or use R. And when you launch them, a virtual machine gets launched and you get allocated resources. And then you work on that, and you're very short and you're effectively beside the data in the data center. So you very short download times. I'll give you an illustration of this in a moment. And some of our colleagues also have been working on this, and they created what we call processes, where they combine the work they've done on virtual machines, and then they publish it for other people to run those machines themselves without having to do any major setup. So I'll just give you an example here. This is Ocean ICU. It's an Horizon project looking at ocean carbon, and they've got a demo running up on EDITO at the moment. There's a link is there. And what they were making use of is the vast storage capacity that's been made available through the EDITO. Their project didn't have, or was struggling with the storage demands that they required to query and subset the outputs from climate change models and also other types of models. But for the EDITO project, we just said, well, here we have the capacity. Just move your demo over to us, and then you can start working with it. And it means that it's a worry, a technical worry they don't need to deal with anymore, and it allows them to get on with the rest of their work. So I'm just going to go quickly onto two more slides, and just to give you an illustration, we had a DigitalOcean forum 2 weeks ago, and my colleague Matteo, who is not IT trained, he's an environmental scientist. He started using EDITO 3 months ago, and he just was using Jupyter notebooks to query, or Python to query the data that's in the lake. And I had tasked him with this to see if he could show the speed advantage for using this, which he did. So what he was looking at here was Copernicus Marine Time Series from the data lake, and looking at the stuff, bathymetry and human activities from the data lake, and just visualizing. He wasn't doing any analysis. He just wanted to see how hard it was. And he just created some Jupyter, some Python code and a Jupyter notebook, which he's going to make available in the tutorial section of the EDITO dashboard, so you'll be able to see it later in the year if you want to start working with this stuff, and to show what can be done with not very much effort. So we did an example where he accessed the ZAR datasets. These are this is netcdf files that are in cloud optimized format, and he was looking at the bathymetry one, and he was able to show that if you used his laptop, it would take 10 minutes to visualize the scene you have there. whereas using it in EDITO, it only took 1 minute and 22 seconds. So there's lots of large computational power available for rapid processing, but at the same time, for him, there was a high coding learning curve, but it wasn't impossibly high. He did get there, and he's looking forward to building new stuff on top of that. So that's what I wanted to do. I wanted to give you an overview of the journey EMODnet has gone from centralization to make things more accessible to people doing geospatial work, to where we're now moving onto a cloud platform where we're trying to serve the needs of people who want to do digital twinning and high performance computing on our data products, and also want to fuse them with Copernicus Marine data products. So hopefully that's useful to you, and it will spur you on to interesting questions.
Thank you, Conor. Thank you very much. And that was a perfect cadence speed there for us to follow. So thank you. Yeah, really good, informative presentation. It's clarified a lot of things for me, I'm sure for the audience as well. And I see we already have 2 questions. I have several questions of myself as well. So let's just jump into those. So we have first question. Well, first of all, I wanted also to say that I don't know if you had a chance to see our participants, but they're kind of dialing in from all over. We have Brazil, Nigeria, India, quite a few in Europe as well. So wonderful to see that this global community is coming together to work on this issue, on how, not only to collect ocean data, but also how to better manage it, how it can be useful to all of us, and how we can use all of this for conservation and protection and better management of the ocean. So I'm really excited to see all of our attendees here today. So yeah, jumping back to the questions. Fabio from Brazil, his first question is, how do you handle data quality assurance?
Okay, so this is a question that we get asked a lot, and this is going to sound like a bit of a cheat, Fabio. But the reality is, EMODnet we're data publishers. We're publishing data products, and the quality assurance goes down the stream towards the data aggregators, like the activity subject matter experts, who are getting their data from scientific programs from member states. But we do create metadata descriptions all the way through the products, so that you can follow what went on in the background. So we don't actually collect any data ourselves. So I'm sorry, that's a bit of a cheat answer, but that's the reality of the situation.
That's how it is. Yeah.
Yes.
Okay, great. Thank you. Next question from Florent, and he's also from the Atlantic and Arctic Agora project, which is one of the Mission Ocean projects here in our region. So welcome, Florent. And he's focusing on restoration of marine and coastal ecosystems, working to develop digital knowledge system. So his question is related to link. My questions are related to link our digital knowledge system with EMODnet and EDITO. Is it possible to use a common repository digital space for data sets collected from our demo sites? That's first question. How is the procedure to get data and to fuse data from various sources? That's the second question. And third question, is it possible to use EMODnet tools or EDITO tools to do this?
Okay, I'll deal with each one separately. So the first one was about looking for a common data repository. Was it for these projects? That's something we're looking into. I can't actually, from an EDITO point of view, it's not something I can commit to or say that we can in the short term. We do have an EDITO 2 starting later in the year, and it's something we're considering. But I can't guarantee that. It is a problem we do have in Europe, is that we're told we have to share data, we have to make data interoperable. But then when they come to doing it, somebody has to pay for the storage of the data somewhere. It doesn't store itself. So I understand where you're coming from on that. You can actually submit your data if you want into EMODnet through the data ingestion system. All our services are open services, so you can link straightly into to our services if you want. If you make your data available to OGC web services, then other people can link into you. And then the third question was on tools. Yes, there are plenty of tools in EDITO, so you need to be in EDITO. We do have tools available in certain aspects in the tools section of the EMODnet web page. So if you have a look in there, or if you want, you can always just reach out to the subject matter experts, the thematics. Each of them are contactable through the website. If you just email the secretariat, we'll put you in touch with them. So if your questions are on biology or geology or whatever, we'll put you directly in touch with our experts, and they will be able to answer you directly. So there's a couple of different nuances to that in my answers there, but hopefully that will cover a lot of what you need.
Okay, thank you. I see, before I go to Bernal, I'm just going to go to Marta, who's left 2 questions in the chat. Marta has written, EDITO is linked to other digital twins from terrestrial ecosystems, or how is EDITO linked to other digital twins from terrestrial ecosystems? Because she's pointing to the fact that this is essential for land-sea interaction issues.
We are at early stages, so we're just coming out of the beta stage, beta testing stage. We are looking to integrate with the Destiny E program. We are also very much based on interoperability via OGC services. So you could pull in stuff from Copernicus Land Observation Program. So there is lots of different ways to do it, but our goal is not to be the total solution. Our goal is to be the horizontal services that others can build solutions on. So we are trying very hard to make sure that all these different ways of interacting with other systems are available through our system, and then we want people to come and use it. It was very clearly said to us when we got funding for this from the Commission, it's not our job to build the products that other projects will be building. It's our job to make sure that those projects are not hampered by the services that we are providing. So that's what we're really keen on. So we have a new program next year where we're inviting more people to use the system. So maybe if it's something you want to work on, you can look into submitting or looking at doing that next year. Yeah, the semantic server, that's a question that's always coming up. We have, there's nothing at the moment on that. We are possibly doing that semantic catalog server as part of the project, but we EMODnet are tied into the Otis Ocean Info Hub. Berks Marine are also tied into the Ocean Info Hub, and we both have rich catalogs of metadata. But they're and we publish our metadata as OGC standards, so it's possible for somebody else to create a catalog out of our catalog and create other catalogs. But I hear where you're coming from, and it's something that's on our mind. But I don't have a direct answer for you on that one.
Okay, thank you. Now moving to Bernal's question, which says, thank you for the lovely presentation. And really interesting question here. He says, the person says, there is a lot of potential here for bringing in this physical world data in game developments or the metaverse with this efficiency for science education communication. I wonder if this could lead to volunteer communities like an open resource map project along the spirit of OpenStreetMap. Is there anything like that out there?
Well, I suppose in the aspects of citizen science, we have these type of projects. There are projects that are trying to get data from old archives, which are open up to citizen science. So we have citizens digitizing we're looking at digitizing biodiversity data from old catalogs or old documents. And then there's stuff where we have sensors on sailing boats as part of the citizen science program. But they're all bits here and there. There's no big overall reaching project because of the nature of funding. But it is a great, it is great. And what we'd like to have with the EDITO is to have the back-end services, the data services, the data storage service to enable people to do this stuff with our products. But once again, it's not fully answering the question, but it's something that we do think about. And our goal is to make sure that we're not the people holding people back.
Yeah, this is a big part of the mission notion is citizen engagement and citizen science as well, and that's part of our hub too. We're very much focused on citizen engagement and co-creating things. So along maybe a similar line, I have also a question, which was how will EDITO support activists and citizen science in their efforts to protect marine and coastal environments?
So as I mentioned earlier on, all EMODnet products are open. So you are free to do with them whatever you want. So go out there, use them.
Go out there and produce.
Yeah.
And I'm glad you gave the example of your colleague who wasn't, maybe doesn't have quite the experience of the tech side of things, who did explore and was able to map some data there that you showed. So it is accessible to let's say people without the skills like myself.
Yes, well, we try. I
this.
mean, there's obviously a limit to what we at some stage, but we do, for example, in EMODnet, we have a thing called the Atlas of the Seas as well, which is more aimed at education. In that case, EMODnet products are turned into information to help, and it's very much used in schools in Europe. I recommend that people look at that. It's a very good system.
Okay, great. Because ultimately, I mean, this is also a very critical and important tool for decision makers, not only in Europe, but internationally. So there too is so yeah, the use of these tools by international policymakers for sustainable ocean management. How I know you said that anybody can go and use these tools, but how likely will they, you think, be going to your tool and using to, assess?
Yeah, well, just to come back to that. So if you go look at the European, look at the work of the EEA, for example, the European Environment Agency, they do an analysis on the officially reported data from member states, which is grand. That's what they do. They build do their analysis and look at their indicators based on that. We have that data, and we have other data which will not be part of their official reporting process. It's not a conspiracy or anything like that. It's just not what they have certain sensors which are allocated in certain ways to meet the needs of their reporting. And we are actually involved in a program at the moment with the EEA to look at how they can fill in gaps in their knowledge using the products that we are developing. Because our products are based on scientific programs or which come from member states or individual research institutes, and they want to evaluate the quality of those and see if they can fill those gaps. There's certain areas, certain parts of the seas around Europe, there are gaps in our observation capacity, and they want to get that sorted out. This is a very real world problem. It's, there are genuine gaps that we have that we try to sort out.
Yes, because data is great, but if somebody doesn't know it exists or doesn't know how to utilize it, and even correctly, maybe if I can say, then we maybe miss our mark of what we're trying to achieve, all of us here as a global community.
And also, just to add in, I mean, we talk about AI and semantic web and all this, but at the end of the day, it's usually somebody somewhere who's keeping tabs on what their member state is, what their own particular country is producing. And it's tapping into that knowledge to try and find out where all the data is. And people just forget where they put the data, which may sound surprising. Or somebody may pass on and haven't told where it is, or they just produce the data. They think they only need to produce the data for official reporting, and they don't worry too much about the other stuff. So there's always that human element in trying to find data for data products.
Yeah. And by the way, I don't want to forget to mention that you are looking for Arctic data. So if any of our participants today are in the Arctic or know of colleagues in the Arctic, please let them know that Conor is in need of Arctic data. I see another question in the chat from Eric. Is OGC connected system standard on your roadmap?
I'm not familiar with the connected system standards. Is this their new API? If it is, it's not on our roadmap, not for the website, not for the EMODnet portal. It's EMODnet portal is, we have to be consistent in how we publish our products, because people build things on top of them. So we can't just change the APIs or the web services because it will break downstream the things that people are using them for. We can certainly look into it as an auxiliary service if there's a demand for it. But I think you're talking about the API, the new OGC API. I may be wrong there. But it's not something I've thought about immediately. We're really, centralization was a huge task. And we're really, at the moment, focused on making sure we have consistent metadata across our products and consistent OGC APIs to access those. But we're not closed to the new ideas. Just need to have other things we have to consider when we take them on.
So we have a very educated audience here, because that's OGCs, yeah. Also, we wanted to touch upon the early career ocean professionals, because that too is very important. It's part of the mission ocean. And so what skills and will these early career ocean professionals need to do this kind of work when working with advanced technologies? Because we're aware that our landscape, if you will, is changing so quickly. Our technology is evolving so quickly, and I think students today are, well, I hear many are not sure what the future has in store for them and what kind of jobs are becoming available. So maybe if you could speak a little bit to that.
Yeah, well, I suppose I can refer back to my own career. My master's is in environmental science, but my primary degree is on mathematics and computers, which I didn't enjoy, to be honest with you. So when I went into environmental science, it was fantastic. I really loved it. I think it's a fantastic subject. But I realized that there was a huge need for people with IT skills to help move environmental science along, move along the data publishing. So from my own perspective, if you have IT skills, you'll always be valuable in the environmental sciences world, because if you were genuinely concerned about the environment, you have to make, you're in a situation, if you are purely interested in IT, you'll make a lot more money working in IT. But if you're willing to focus on the environmental sciences, you won't make as much money, but you'll be a lot happier.
Okay, we've got a few more. So we've got a few more questions. I hope you have some extra time, if that's okay, Conor.
Yeah,
I see we only have about a minute left, and I still have 3 or 4 questions. So we have, I'm gonna say this name wrong, Pito, maybe. Do you provide or consider EDITO users products exposable, though web services based on EDITO toolset? Oh, through web services, probably. Mm-hmm.
So at the moment, the only products up there are EMODnet products and the Marine products, and they are open. They're exposed through web services, but they're also directly open. The stack catalog is actually available to the public. You will see, if you go through the stack catalog, you'll see the links to the actual data product on the data lake, and you can download it directly from there. So we're trying to make stuff as available in many ways as possible.
Going back to the ECUPs, Martina asks, is there the possibility to compensate ECUPs and researchers for their data upload contributions?
Very good question. That's a policy question rather than a technical question. So from a technical point of view, there's a compensation that your data is stored. Now we haven't opened up the EDITO for that yet. But the other question is a question of policy, but what the Commission is willing to fund. So it's not in my wheelhouse on that one.
Yeah,
But if you are in a situation where you're putting stuff onto EDITO, you're not going to be charged for the storage of data on EDITO.
Yeah. Okay. So I want to kind of touch upon the businesses and entrepreneurs, because we might have some in the room, and obviously also the Mission Ocean is very much about innovation space. I understand that obviously digital twin of the ocean is going to be a very beneficial tool for them in acquiring data so that they can maybe forecast scenarios or good placements to put maritime sector businesses. That's maybe one. I don't know if there's anything else. Also, I mean, I'm sure there's a lot more, but if you want to expand on that a bit more. But before you do, the other side of that too, though, I was thinking while you were sharing your presentation, is also the benefits to pension and insurance providers being able to access this data so that they too can do an analyses, risk analyses that they face. But the other side of that too, that I'm really interested in, is for investors, because we do have a huge gap in funding for the marine ocean space. So how might this tool help us fill that gap, with funders understanding better the marine risks?
Yeah, well, I'm back to the point of making about we're trying to make our services more robust and scalable for people to do that type of analysis on. So you're in a situation where research projects could actually work on EDITO, the digital twin of the ocean, on massive data, big data sets to produce products that could be consumed by insurers or analysts. But at the same time, these companies can also access the data, will be able to access the data products stored in the data lake and either and download it directly if they want to work on it offsite because it's open data. And they can be assured that the services will be available in a much more robust way than they have been before. I think it's as I put out, where we are trying to provide the data services to allow other people to do the innovation. The music there, right? Can't hear you. You're muted, Valerie.
How did that happen? Sorry. Sorry about that. I was just saying that these will be the last two questions, if that's okay.
Okay.
And that I have a question that came through YouTube, and it says, how do you quality control citizen science data in EMODnet and EDITO Lake?
Well,
the data lake.
As said, this goes back to the thematic assembly group or the subject matter expert group that are creating the data products. They look after the quality control because those citizen science data, the data lake is only there if it's been used for citizen science data, which it hasn't been yet. It's only there to host the data while it's being processed into a product. So we don't, in the technical side, deal with any of that. It's up to the subject matter experts who are experts in their field, i.e. marine litter, for example. They have very extensive quality control systems for the data sets. For the data sets, they turn into data products. And that stuff is up on the EMODnet portal in the documentation and the reports from those, say, from marine litter, if you want to go there and have a look.
Thank you. And then in terms of the Arctic data, what sort of data is needed, just to put it out there already on this platform?
I wasn't told. I was saying earlier on to Valerie as I was I was coming to this meeting, one of my colleagues shouted out to me to make sure they let them know we need Arctic data. Didn't tell me what Arctic data. So
okay.
If you want to contact if you have anything, contact the data ingestion team and they will direct you to people.
Okay. Wonderful. Well, thank you very much. Any last kind of parting words about this project and your journey on this project? Any major challenges or what you're most proud of?
Oh, well, in this project, the team that have built the system, they're amazing. I mean, we originally when we came up with the idea, it wasn't as good as this. The team that really got into it and they built a fantastic system. And what I find really exciting is the potential for what people can do with this going forward. As far as we understand, we're the only marine data lake that currently exists. Now, I'm sure there might be another one elsewhere, but I've looked around. And it's an ideal way of fusing data products from Copernicus Marine and EMODnet. And we also are looking at bringing in other data products, climate change data and Earth observation data. And it's one of the other things that really driving me on this is to try and modernize our IT systems, because computers get faster and cheaper and faster and cheaper, and the tools get easier to use, and the coding standards get easier to use, and Python's much easier than C. All these things are as you go on. But if you don't have the back-end systems to support the usage of these modern software development tools, then you're being left behind. And I don't want our community to be left behind. I want them to be using using Python or R or whatever to access these big data and do the processing at the best that we have available, given the funding that we have.
Thank you. I want to thank you again, Conor, for this, for sharing your time and your expertise and also your passion. It's really very super interesting. Looking forward to myself diving in and using this a little bit more, because I should be. And also want to thank our participants for the great questions and being so active here with us today. And yeah, just looking forward to the further development of this. And again, Arctic colleagues, please do reach out to EMODnet and share your data. And we're also here, Conor, if you need us as a Mission Ocean hub.
Thank you very much. Thank you very much
Thank you
for the opportunity to promote all this.
Thank you. Bye, everyone.
All right. Thanks, Valerie. Leave you to it.